we are to create these virtual machines, the main idea is to create a virtual machine monitor. And so this virtual machine monitor creates the illusion of multiple virtual machines on the same hardware. So this virtual machine monitor is also known as a hypervisor. So once we create that, we would have all these advantages. If one of the machine fails, the other ones would still run. It would be less expensive for us, and migrating virtual machines for load balancing or other purposes would be much easier. We have 3 requirements to make that possible for virtualization. The first requirement is safety. So hypervisors should have full control of the virtualized resources. In other words, we should not allow the guest operating systems to access, for example, disable interrupts or modify the page table entries. That's what we mean by should have full control of virtualized resources. So fidelity, the behavior of a program on a virtual machine should be identical to the same program running on bare hardware. This means whatever the processes are doing in the virtual machines, there should not be any difference of what they would do if they were running outside of a virtual machine in a normal operating system environment. So that's what we mean by fidelity. So the virtual machines should not realize that they are running in user mode. Why? Because the virtual machine is an operating system, and the operating system needs to run in kernel mode. But if it's a guest operating system, then it doesn't actually run in kernel mode. it runs in user mode. So we need to make sure that the behavior is identical to a regular operating system, so the virtual machine should not realize that it is not in kernel mode. And then efficiency. As much code as possible from the virtual machine should run without intervention by the hypervisor. Because if every time we have the hypervisor intervene, we are causing performance issues because that's very slow. So we're trying to speed up the virtual machines. This means as much of the code as possible should run without the intervention of the hypervisor. Let's see here. How do we make sure that the virtual machine does not realize that it's running in user mode? So that has been solved in hardware by the CPU manufacturers, which was Intel and AMD, that first proposed something called a virtualization technology. Or VT. So Intel and AMD created this. Each one created their own version of this virtualization technology, but they're pretty similar in the way they work. And what they do is they create containers, and inside these containers would run the guest operating system until it needs to trap into the hypervisor. When it traps into the hypervisor, the possible ways that it can do this are controlled by hardware. So as we have already said, we need to make sure that doesn't happen very often, because every time that happens, it's very slow and slows down the virtual machine. So efficiency, when we talk about efficiency, we need to consider two types of instructions. We have what is called sensitive instructions, and privileged instructions. Sensitive instructions behave differently in user mode when they run in user mode than when they run in kernel mode. And the privileged instructions, they require kernel mode to run. type of instructions that we need to focus on when we think about efficiency.